Thank you for joining us. I think we'll go ahead and get started. My name is Jenny Duvander. I'm the Communications Director with the Institute for Sustainable Solutions. This is the last in our weekly lecture series for the fall. We'll resume again with the Solutions Seminar series on January 11th. Next term will be in partnership with the Department of Environmental Science and Management with a focus on the theme of ecosystem services. So we hope you'll join us again in January when our lecture series resumes. Welcome also to our viewers watching live online. We welcome your questions on the Solutions Journal website where we're live streaming right now. And wanted to just briefly go over tonight's agenda. After the talk, we'll have time for brief questions and then an opportunity to continue the discussion over refreshments. So please stick around. And for those members of the class in attendance or watching online, your paper is due next Wednesday at 5. So please submit that on time to the same email address that you normally submit your weekly assignments to. And now I'm pleased to introduce our speaker. Dr. Tugrul Daim is Associate Professor and Director of the Technology Management PhD program here at Portland State. He's the co-director of the Research Institute for Sustainable Energy in the Department of Engineering and Technology Management, and he's also a fellow with the Institute for Sustainable Solutions. He previously worked at Intel for over a decade, where he managed product and technology development. He also has consulted with many organizations, including the U.S. Department of Energy, the Energy Trust of Oregon, Biotronic, Elsevier, and many others to develop technology roadmaps for their future investments. He's editor-in-chief of the International Journal of Innovation and Technology Management and the North American editor of Technological Forecasting and Social Change. He received his bachelor's degree in mechanical engineering from Boğaziçi University in Turkey, his master's in mechanical engineering from Lehigh University in Pennsylvania, his master's in engineering management from right here at Portland State University, and then his PhD in systems science with a focus on engineering management also here from Portland State University. Please join me in welcoming Professor Daim.
Thank you, Jenny. So thanks for coming to this seminar at 5 p.m. on a Wednesday afternoon, taking time from your busy schedules. So I'll start with my basically, how would I say, entrance or push into the energy sector or the implementation of these methodologies in the energy sector. When I was giving a lecture or a seminar at one of the federal agencies and telling them about technology roadmaps and how basically it addresses or how they need to understand their customer drivers and customer needs, I was shocked to learn that basically they didn't have any customers, or that's what they believed in. They said, or the funny thing was to learn that their customer is really the U.S. Senate, because that's what all the federal agencies are responsible to. So that was an interesting change for me after basically I worked over a decade at Intel, where everything was due yesterday. So the whole corporation has been driven by one of the founders' vision, which was only the paranoid survives. That's some of you might know Andy Grove. He was one of the founders, and he was one of the former CEOs. So today I'm going to talk about how we've been implementing technology roadmaps, what they are, and what we have done or how we implemented them in the energy sector. So we're going to start with briefly talking about technology management. So I mean, if you have paid attention, I'm in a kind of a cross-disciplinary department. So you have engineering, technology, management. So it's kind of, so what is it, right? So management and technology engineering. Well, tell a bit about what technology management is, and then I'll kind of place roadmapping in that whole technology management spectrum. And then I'll talk about what we've been doing in terms of implementing this in the energy sector. Yes?
We need you to say that microphone
so they won't hear me, huh? Okay. All right. I won't walk. So, if you look at the dominant forces in society over the years, we've been basically moving from one major force to another. And the 20th century was mostly driven by manufacturing. Now, given this history, several people have been trying to define the era we're in. So are we in, again, because a lot of people think it's not industrial era anymore, it's not manufacturing, and it's been called by most the technology era. And the characteristics of this era are basically the attention or focus on research and development, attention on creativity, the discontinuity or disruptiveness of innovations, and commercialization of these ideas. So there's been an emphasis on these through that era. So that's why one of my mentors, if you will, he's the founder of the discipline technology management, Dündar Kokaglu, calls this era as the technology era. Now, why do we have to care? I mean, how is this changing what we do? So we have several things that are changing. For example, in the organizations, instead of having co-located groups working on product development or technology development, we now have virtual teams around the globe. Now, that's been kind of going on for at least 20 years now. So that was another thing was surprising for me. When I first started at Intel, it's about 20 years ago. So they said, okay, so we have a meeting with Puerto Rico. So you get into a room, you have that phone or audio conference device there. So that's not new. But what's happening is we've been it's happening with outsourcing. We've been using that for everything, meaning just let's go virtual on everything. But it doesn't work always. When doesn't it work? When you basically need the attention of all functions working together. It doesn't work when you're basically working on a very new technology, breakthrough technology. So I've been I've been the program manager in some of these cases when we had these challenges where we had team members in different parts of the world, whereas we had to have them here. So you have to be careful what to virtualize, what not to virtualize. Now, the other thing is employees. Now, again, 20 years ago, when you went home, that was it, right? You didn't have access to your computer. Even many of us didn't have computers at work. Now, basically, you have access to your work 24/7. Now, I'll give you an example. So my wife works at Intel, and her computer is basically open in our bedroom. And whenever an email comes from her boss, let's say at 9, 10, 11, it doesn't matter. She sits down and responds because that's kind of the responsibility, whatever she has. So you have to be careful at that as well. So meaning you have to manage that stress on your employees. So yeah, everybody's working flexible hours, but you have access to these people 24/7, and sometimes people tend to work them 24/7. And of course, suppliers within a geographic boundary from basically just local boundary to a global supply chain. Now, it's interesting. Another mentor of mine, Harold Lindstone, he's actually the one that started or is one of the founders of technology forecasting. He calls it globalization. So while we have global forces, we also have local forces. For example, in the recent years, less than 10 years, I would say, we started to have these local grocery stores, like New Seasons is an example, right? So it's an interesting phenomenon going on there too. But again, the global supply chain is good in one respect, and you have to be careful in another one. Again, when you're dealing with, for example, breakthrough technologies, you just want to make sure that you have your suppliers close to you. They understand your issues. And again, you want to kind of make sure you benefit from the economies of scale, but just you have to pay attention to your technologies, because there's been, again, there have been several failures because of that, because of not understanding the globalization issues, not understanding the language, the cultural, etc. I'll give you an example. When I was at Intel, I was basically introducing a product to 5 different regions in the world. So one of them was in Asia, one in Europe, one in North America, one in South America, and one in Central America. Now, and then what we did was we developed a scorecard to evaluate how we did in the introduction. And generally, we got good results from all the regions, but the Asia region gave us 35 out of 100. So average was, let's say, 90. Okay, so that was a problem for our manufacturing engineers, because that goes on to their reviews. So we asked why. I mean, why did you guys? What did something happen? They said no. So was everything delivered on time? Yes. So why did you give us 35? So what we learned, again, I mean, we're the same company. They are the Asian group, and we're here in Oregon. When you meet something in their culture, it's a 5. You get a 5 out of that. In order to get a 10, you have to do something that someone hasn't done in decades. So that was interesting learning for us. So that we said, no, that's not how you do it. So if you meet the deadline and you deliver what is agreed upon, you give 10. So you have to be careful in understanding these nitty-gritty details, which may actually result in failure. Anyway, so why do we care? We want to be basically we want to avoid being slaves to technology, like just being in front of computer all the time. So you have to understand the strengths of technology, how you can use it, but you have to just manage it. So technology management is a vast area. So we have a master's program and a PhD program at Portland State. So we have several master's students and 2 of our PhD students here listening to the lecture today. So if you want to learn, I strongly suggest that you look into taking classes or even taking the degree. But one of the important things, or the initiation of technology management, is strategic planning. And that is basically what do you want to do? So what do you want to get out of life type thing. And once you identify what you want to do, given what kind of organization you are, you start identifying the technological gaps that you need to basically fulfill to get there. And road mapping, in this case technology road mapping, helps at that step. So that's what we will talk about today. Now, what is technology road mapping? So technology road mapping is really a comprehensive approach linking your drivers, if you will, your customer drivers in the case of a customer-driven organization, or general drivers, like the case of federal agencies, in the case of other organizations, to your R&D actions. So what in other words, if you're given money to do research and development, where will you invest it? So you need to basically be able to link these to your strategy so that you can know, you would know what to invest in. Now, again, at Intel is a pretty much roadmap-driven organization, so everything needs to make sense in terms of linkages to their strategies so that they would invest in terms of R&D. Now, in the energy sector, I've learned in the past 7 to 8 years that things haven't been that way. So it's changing. It's changed. But for example, recently we have completed a technology landscape analysis. So technology landscape analysis is basically evaluating what kind of technologies are out there in a specific area, who's developing what kind of technology for what kind of purpose. So we did it for energy storage technology. So if you're wondering what energy storage technology is, it's really very much to do with the whole sustainability idea. So we're talking about renewable energy such as solar, wind. Although it's a nice green thing, one bad thing about them is that they are intermittent resources. Meaning, in the electricity, before I went into electricity industry, it didn't really hit me that you really cannot store. I mean, the technologies are kind of emerging. The electricity that well. So you need to basically generate it and use it. So, for example, in hydro, so in June and July, we have so much water, we just have to use it, so we have to stop wind generation, for example. So in that respect, the wind and solar, we don't have them when we need them. For example, we generally use most of electricity in the morning when we wake up before we go to work or school, and when we come home in the afternoon. But we don't have wind during those times. Wind is generally up in the evening. So the idea was, one of the issues in the energy sector is development of more feasible energy storage technologies. Anyway, so when we started looking into that, we identified a lot of projects funded by the Department of Energy. It's a new program. Actually, it's a part of a program called ARRAE. That's really a part of the stimulus package. So we found that California has a lot of projects. And then we went, and then we were having a problem here trying to understand, okay, so yeah, let's do landscaping. What do we use it for? I mean, what is the metric we need to understand to measure so that we could go do the landscaping? And we found that it's really the amount you have to increase or decrease generation. It's called inks and decks in the electricity industry. So we went and asked them, I mean, all these guys investing a lot of money into battery deployment, and many of them didn't know, and because they had the funding they are using. So the idea is you have to basically know so that you could invest the money more wisely. So that's the idea of road mapping, is to link it to the overall the strategies of your organization. Now, the roadmap process is claimed to be, or Motorola claims that they started first. So, and they actually also define it as a way to look into the future, to see where you want to be, or to define where you want to be, and then determine the next steps or next set of steps to get there in terms of R&D investments. Now, it has several values for the organization. As I've been repeating myself, it links the strategy to the product plans, technology plans. It enables technology planning, and it basically establishes more focus on the longer-term planning instead of just being myopic and just focusing on the next year. And it really enables communication. So when you want to basically communicate what I need, or what I need from a research lab, or what my goals are, you just send the roadmap. So, for example, a typical question at high-tech companies is, where is it on the roadmap? So you want to do something, where is it? I mean, which product or which technology will it impact? And of course, it also helps the priority setting, as you need to basically identify the technologies or products matching the needs of the strategies or the needs. Now, the generic format is, I'll just build this. So you have a market need over here. And you basically then, given here, how can we get, since we're here today, how can we get from here to there to address that market need? So we have to have a product launched at that time to basically address that market need. So that product has a certain development time. So meaning we have to have technologies which will deliver certain features of that product, if you will. For example, what iPhone has been doing with Series, right? For example, that technology. And that technology needs to be then developed throughout this time so that it can be ready for this product, which, again, uses the results of an R&D program, which will, again, start today. So the idea is you basically link these steps. Now, this is a generic format, and it would change from organization to organization. For example, when you go to regional organizations, they don't have markets, right? But they have regional drivers. Instead of products, they have capabilities that needs to be fulfilled. So those terms change depending on the case. Now, the applications, again, differ based on whether or not it's focusing on the industry or the specific technology and the product. And they all have different reasons. So we'll talk about some of these by giving some examples. For example, science research roadmaps. It's really to communicate the convergence of different parts of different science fields and showing how they are converging, for example. Cross-industry roadmaps to basically develop a standard or a standard message to your suppliers or customers for a specific industry, so that the standardization can happen. So one example in this case is the semiconductor industry, which is really based on, or which is really dependent on semiconductor manufacturing equipment. And the equipment manufacturers have been working with the product developers so that the equipment can be standard. So these types of, again, roadmaps provide or communicate where the product features will be at certain given time so that they could be ready with the manufacturing equipment. There's another one for hydrogen economy. It's really showing what kind of technologies are needed when to reach a certain vision. So it's really, again, helping to develop a long-term plan and prioritize it. Others are, for example, specific technology roadmaps, meaning where the technology will be in terms of capability at a given time, and which, for example, foundry or which factory will be enabling that type of technology. Or you could also link that to the products, meaning, okay, which year will you be introducing or intersecting which technology so that you could develop your product plan. Product technology roadmaps, again, showing the products given different markets and the technology features. So these are very good roadmaps to communicate your products to your customers as well as to your suppliers, your needs to your suppliers. Now, the ones that we've been looking at is really helping the planning. So that's why the ones that I want to focus on have drivers identified, products, technology, and resources. For example, this one is a 3D display technology roadmap for television, and certain drivers in this case was the Olympics and products and several different technology categories and resources. Now, one thing about roadmaps is, and I'll show you in a minute, they don't just happen, meaning you don't just have a blank template and you put things on the right and then come up with a roadmap. So each level needs a lot of assessment and analysis, meaning you have to go work with your customers or regional stakeholders to identify what the drivers are. And then you have to basically look for the existing products and other product features that might be needed. And once you have these, for example, you will have a lot of data. It's going to be a mess. So you need to start organizing them. You need to look at, okay, so what kind of logical product feature sets can I have, so that you could basically come up with some product ideas. For example, a facelift or a radical technology. Those are terms used by our colleagues in Cambridge, which actually have been very effective in commercializing this process. And then when you look at technologies, you will also have similar confusion. So what you will need to do is categorize the technologies, which actually might help you to organize your technology development organization. This is another one, again, the 3D display technology roadmap for mobile applications, and again, different drivers, different products. Now, things get complicated when you, for example, look at the case of a country. This one was done for Thailand, looking at basically how to enable the hard disk drive industry throughout the coming from 1990s into 2015s, what should be done, which organizations need to be involved. So we have tried to do one for the basically deployment of electric vehicles in Oregon. As you can see, it can get pretty complicated. So what you need to do then is you need to start basically grouping these drivers and products so that you could make sense out of it. And I'll show you how we do that. Now, to a degree, you could call technology road mapping an art, meaning as you collect data, you need to look at how that data is shaping up so that you could group it and make sense out of it. And it's used for different purposes, as you can see, and you could, again, have different approaches in terms of describing the drivers in the roadmap. Like I said, there's a lot of work that goes into it, meaning you need to be doing this background work as you populate the roadmap. Now, this is the, for example, how a roadmap looks like. Again, this is for wind turbines. The drivers in this case are different market shares in this organization, and these are the products to be introduced at certain times. These are the technologies and the know-how needed to develop these technologies. Now, again, like I've been saying, it looks nice when you look at the end result, but again, you need to adopt a logical process to get there. And this is an approach developed by Rob Fall from Cambridge. It really, you want to start with brainstorming, and in that way identify key drivers. And then go and define, okay, given these drivers, what's our vision? Okay? Then identify the current situation where you are, and use the road mapping process to chart your, basically, map to reach your objectives. And on the way, highlighting the key risks, enablers, barriers, decision points. And the roadmaps can be, in most of the time, customized per your objectives, which I will again give some examples in a minute. So, for example, this is the kind of the initial brainstorming of one. As you can see, how that basically gets populated with your, again, this was done in a workshop. Now, let's talk about the case and the one that basically is related to the Institute of Sustainable Solutions, so the Northwest Energy Efficiency Technology Roadmap. Now, why technology roadmaps in the energy sector? So this really started in the Bonneville Power Administration, and it was the year when I basically quit Intel, came to PSU as a full-time faculty, and BPA contacted us, and they basically wanted to learn about technology road mapping. The problem, and actually this was the vision of their Chief Technology Officer, Terry Oliver. The problem was the changes in that sector. So when you look at this is from NSF, and it shows R&D investments as percent net sales. So, for example, here you have organizations like software, communication equipment, computer systems, semiconductor companies. So all the usual suspects who've been investing into R&D. Guess who do you have up there, the top, next to zero? Utilities. So that was the problem, meaning they, through different reasons, including regulation, meaning, you don't have any competition, you have a set market, so there's really no motivation for investing into R&D, to basically a situation where technologies are changing, there are a lot of demand is changing, so there's a need for investing into technology, but since you haven't done it for a long time, what will you invest in? So that was the problem. So that's why they came to us and they basically asked to learn about technology road mapping. And for example, one of the problems was the one that I mentioned about the intermittency of the energy sources or electricity generation through renewable energy sources. So all these needed further R&D. Of course, in the recent years, the stimulus package and the emphasis on energy has been helping this. Now, the Northwest Regional Energy Efficiency Roadmap was really done by a group of regional stakeholders. So, as I said, we started working with BPA, and then the Northwest Energy Efficiency Alliance saw that effort and how that was influential. So they wanted to develop an energy efficiency technology roadmap for the region. So around 30 organizations were involved, and the idea was, okay, so where should we invest as a region to reach our energy efficiency goals? Now, in this case, to identify the drivers, we looked at what is called the 6-power plan. So that defines and agreed upon regional goals. Now, energy efficiency, again, I'm not the expert on energy efficiency, but over the years I learned that you really look at energy efficiency as an alternative to any other power plant. So instead of a hydro plant or a coal plant or a nuclear plant, you could have an equivalent of energy efficiency programs so that you don't have to build any of those. So the 6-power plan has such goals to reach in the next 30 years or so. So we were looking into, okay, what should be done to get there. So we held a series of workshops, and like I indicated, we started with existing documents to come up with an initial set of drivers, which we took to the first workshop. And the first workshop, we had all the people with the knowledge of drivers in this area from these organizations. So we set the drivers, and we again used different group methodologies to have them go through the drivers, eliminate some, add new ones, so that we could agree upon a set of drivers. And then once we agreed on that, and we basically agreed on the landscape, we started reviewing the product and service features that are needed to address these drivers. And then the next thing was, okay, so what are the gaps? So we identified two groups of gaps. One was, okay, does this feature exist, but the product is not diffusing? So that's gap one type of gap. The other one is, does this feature, not in existence, is this feature not in existence at all? So it needs to be developed. So that was basically a 2-day effort, and that basically helped us to identify all the gaps. Now, the one thing to do, or one lesson we learned, was to make sure you validate the outputs of the workshops every time. Now, of course, when you're developing a regional roadmap, everybody has an opinion. And since you have to involve everybody, you cannot really measure everybody's expertise on these opinions, right? So, and you cannot just say no to them either. Meaning you cannot come to the workshop, so you cannot do that. So what we did was, we had a third party who was basically an energy efficiency expertise who reviewed and verified what was told. And that was basically, after every workshop, we had them go through it and just validate what we've been hearing. Now, the next thing, we held 2 parallel workshops. One was focusing on those products and services that were not in existence, and the other one, the ones that were not diffusing well. So the ones that didn't exist really focused on technology. So for that workshop, we specifically invited the technologists from national labs, from universities, and these organizations. And the other one was mostly focusing on marketing initiatives, because that's the problem. Why is this Why is it not diffusing? What can we do to help it diffuse? So that we mostly involved or invited the marketing or product people closer to the marketing departments and product groups. So through these two workshops, we identified a set of programs. One group was R&D programs to deliver these technologies that would basically deliver the features for these products, which will, as a result, address the drivers. And the marketing programs, which will again help diffuse these products, again help, as a result, address these drivers. So once we list these programs, we had a final workshop with the key stakeholders in the region to prioritize these, and finally we published the roadmap. Now the roadmap looks like this. I mean, if you Google it, you'll find it. It's open to public. It's somewhere around, I think, 70, 80 pages long. So this is one of the summary slides. It's just showing overall summary of the drivers and the major gaps and the goals to close those gaps and the technologies needed to close those gaps. And finally, the top priority R&D programs identified. We identified close to 100 R&D programs needed. And then through the prioritization, these were the top ones. Now, and these were, again, similarly the marketing programs that would be deployed to help to diffuse the products and services that were not diffusing well. One example of the roadmap page, for example, within the electronics area, the sleep mode technology roadmap. So it basically had the gaps detailed, the goals for these gaps, and the technologies, whether or not they are in existence or not in existence. For example, here the pink indicates that technology is not there, so these white boxes are R&D programs needed, and this number shows the priority after basically the prioritization. I'll just show you real quickly the actual roadmap. So this is the actual roadmap. If you Google it, that you will find. It just starts with who's been involved. As you can see, regional organizations as well as national labs and universities. And then the table of contents just going. This is just the introduction on how to use the roadmap, the roadmap key, the high priority roadmap that I just showed you, which just shows the top 15 R&D programs and the related goals and gaps, and then what those are, for example, shop floor innovative technologies similar to auto industry, or variable refrigerant flow, and then detailed roadmaps. Just you can go and look at different R&D programs and which goal it's helping. Now, what does this do? Yeah, that's good. You find all these. Basically, this gives a prioritization to the decision makers for funding, for R&D funding, which projects they should fund in terms of helping Northwest reach their energy efficiency goals. And that, again, that's been now updated with the new data as of we speak. And we also start getting into other focused areas of energy efficiency in different, sectors. So we will have different energy efficiency roadmaps for different areas, such as food industry or retail industry. Now, these are some of the pictures taken through the workshops. So what were the key learnings? So we basically came up with an agreed upon plan for technology investments. it included all stakeholders, so that means it helped to gain their buy-in, and it clearly highlighted the priorities of the region. Now, key operational factors. So if you want to do it at home, I don't suggest doing it at home, but if you want to do it in other areas, so bringing all key stakeholders together helped. Using professional services for facilitation, meaning somebody taking minutes. It's very important because you're focusing on the process. It was really helpful for us. Using an outside technology verifier. In this case, we use Washington State University Energy Efficiency Program, which again is known nationwide. And then using a program management approach, meaning somebody making sure that every deliverable is there on time so that we have the workshops and then we have them according to our schedule. And then using basically a consultant, in this case this was me, a dedicated process expert who basically just focuses on the process. Now, so what does this mean for policy or for policymakers? So one of the things is that the organizations need to be aware of the fact that they need to invest into R&D in competitive environments. Otherwise, they will be obsolete. Now, and then to do that, they need to have an R&D portfolio, and they need to continuously monitor the gaps so that they could identify technologies to fulfill those gaps with the technology road mapping. Now, what policies can basically organizations adopt so that the road mapping can be adopted? So, of course, the values need to be highlighted to the organizations, and training programs so that people can see how it can benefit. Now, in any process and organization, adopting a new process is a headache, meaning people will say, I don't have time, I have enough meetings and this and that. So unless they see a use, a benefit, a value, they will not use it. So it's always good to kind of show them what it can do, pilot it with a kind of a small project, and then demonstrate the value, and then implement it in the rest of the organization. Now, of course, the policies can help organizations like the Northwest, organizations like the organizations in the Northwest, to adopt these approaches. One is the organizations justifying their R&D investments. For example, when we asked several different organizations outside the Northwest why they invested into this versus that, they didn't know why. They just thought that it was one of the hot things to do, so they invested into it because there was money available for it. So that should basically be discouraged, and what should be encouraged is, okay, so why are you investing into it? How does that help you to reach your long-term goals? And in that way, roadmaps can be adopted by other organizations. So with that, I basically want to end my lecture, and I just want to show you another example. So we're, for example, working on another one. It's transmission technology roadmap, which is another element of electric industry. And I just wanted to show you the different, we call these swimming lanes, if you will, the lanes that we have. So in this case, we started with, again, business challenges. We then introduced a new concept called operational challenges, which would change from one organization to another within that transmission organization, because business challenges can be common and can have different impacts in different organizations. And then needs due to these challenges and capabilities required to address these needs and technologies and R&D programs. My point here is that you will need to customize it per the application, and you need to basically understand the organization to start implementing it. Okay, with that, I'm open to questions. Any questions? Yes? Yeah, you can come here.
Hi, thank you for the lecture. My name is Lee. I'm studying economics at PSU. As you showed in the roadmap, I see there is technology gap and the market gap. But I'm just wondering, do you consider the gap between market and the technology? Why I'm asking is because I've been interested in renewable energy sector, particularly in solar, for 10 years, and I want to do something, but I figure out it's technology breakthrough is faster and faster, but our market is still in the old ways that we're slowly changing. So I'm just wondering, how you will map the gap between those two aspects?
Thank you for the question. So the question is, how do you address the difference between the market and technology? That is really when you're breaking, if I understood it correctly, when you're introducing breakthrough technologies for markets that are not ready, what do you do? So that's the opposite way of what we're talking about here, and that's really that's what organizations who own these technologies, they are the ones who should worry, as well as the government, for example, who owns national labs, which develop a lot of technologies, breakthrough technologies, and then they work on commercializing these technologies. So maybe I'll start with, you could take our courses. We offer a lot of courses on technology transfer, commercialization that talks about that. But of course, that's really what commercialization is all about, and developing programs to commercialize these technologies. When you go to, for example, national labs, each one has technology transfer office, TTO. And universities today also have similar offices. For example, at PSU, we also have a university technology transfer office. And they were not really in existence several decades ago. And their objective is to find areas to commercialize these technologies so that, again, like the market, the delta between the market and technology can be closed. Also, companies, several high-tech companies look at it, do that by collaborating with others, making sure that the ecosystem is ready when you introduce a new technology. For example, microprocessors. That's what Intel has been doing for decades. They make sure that everything is ready, the software, the hardware, when they introduce their processor. One example is back in, again, about 15 years ago, I was in the motherboard manufacturing at Intel. And Intel was world's number one motherboard manufacturer. And the whole objective was to enable the processors so that the processors would have homes when they get out. And again, there wouldn't be any delta between the market and the technology. Although the Intel didn't make a cent on that in terms of profit, the whole effort was enabling the ecosystem. Okay?
Understand. Thank you very much.
Sure.
Also, I just wonder, as a product, when it's B2C product, so it's kind of easy to maybe get that step, as you said, but when it's come to energy, it's more big product, and that it's kind of hard to figure out.
So then that's where government and policies get into the picture. So for example, one thing you don't hear much about at Intel would be policies, because everything is based on strategies. When I came to the energy sector, everybody talks about policies. So policies kind of set the agenda. So that's important. But also important is you need to understand who your customer is and what your customer wants. For example, now we're in the most, I think, green state or city, if you will, in terms of being environmentally conscious and everything. And we talk a lot about electric vehicles, okay? But if you want the electric vehicle to diffuse, you need to make it basically appealing to the customer. So you and I will buy the car. You and I will pay $20,000, $30,000 to pay that car. So why would you buy that car? That's the question that the manufacturers should address, so that as well as the government, so that the technology can diffuse faster. So it doesn't matter if it's an energy or IT. At the end of the day, the customer needs to buy it, right? So we need to understand why they would buy it, and how we can basically convince them to buy it over other technologies.
Last question.
Yeah.
Do you think the energy program that we have now, the hard part to actually to let the renewable energy sector grow, do you think the hardest program is actually deregulated energy sector? Do you think it's a...
So the Secretary Chu, first of all, there are a lot of positive developments. So I didn't know a lot about energy sector up until 7 years ago, but if you ever been to DOE in DC, it's intimidating building. It's an intimidating building. It's like a fortress. And then you then go in and you saw these pictures of mushroom clouds and the atomic bomb prototypes. When you realize that it's really where the nuclear weapons have been developed for the past, 5-6 decades. Okay, so Department of Energy had focused 95% of their energy on nuclear weapons in the past 50-60 years. Now, first time I think ever we have a secretary who's coming from scientific background. He's actually also the first Nobel laureate. I'm not talking about the Peace Award, but scientific awards to be on a cabinet ever. So that's encouraging. So he's trying to really make that change. But again, just 5% focus needs to change. I don't know how long it will take to change that. But he understands that we need to change the architecture of the industry to make it competitive. Because if it's not competitive, nobody will invest in technology. So you invest in technology because you want to stay competitive. And that basically drives the prices so that the markets emerge, so everything basically gets into that cycle. So it will not happen as if we don't change the architecture. But when we talk about that, then people say, oh, look at Enron. So people are scared of the other extreme. So that needs to be managed well by regulators. But it's, again, you have to have the products. Again, it's difficult to compare it to the, again, IT sector, because when you look at, you don't really buy a wind turbine for Christmas. You buy an iPad for Christmas, right? So the drivers are a little different. It's really less personal. So it's a challenge. It's a different challenge. There are some common elements, but it will take some time.
Okay.
But again, like I said, there are some encouraging developments in terms of the secretary and the programs and the focus on these things.
Okay. Thank you.
You're welcome.
Question. What were some of the results of the roadmap, given our limited investment dollars in the Northwest for energy efficiency? What are some of the top and most highest priorities for technology investments to get where we want to go?
So the top investments, I'll just show you. So the high priority programs, if you look at this, so let's look at the top 5. So one was better mini-split controls for variable refrigerant flow applications. So those who are familiar with VRF and its applications, when you look at the air conditioning units, for example, at homes, or in areas like these, just trying to develop or adopt these new technologies which would be more efficient in terms of providing the same basic HVAC as well as the air conditioning. Now, when you go to Europe and Japan, these units are available in every house or office. And you could basically cool or warm a room, and you don't have to cool or warm the whole house. And in that way, they provide very very much, they are very much efficient. So adoption of those and developing again, those would be one example to this type of application. Another one is heat recovery optimization routines such that economizer performance is not impacted, make better use of exhaust heat, air heat recovery and economizers. So we're really looking at, for example, heating, cooling, and how you can make it more efficient with less use of electricity and without, for example, having to heat the whole house or cool the whole office. As well as there were also other things such as weatherization of, again, residential air units, like old houses, and making them more efficient in terms of so that they wouldn't lose the heat. That was another thing. So mostly to make sure that we use electricity in terms of heating and cooling better. Now, in the area of lighting, we have been the region has been very successful in transferring to more efficient lighting systems. So several of us have those, and actually, now I don't remember it quite accurately, but it's either passed or the deadline is coming that you will not be able to buy all these good old bulbs. You will need to have more energy efficient bulbs at stores. So region-wide, again, that's country-wide in that case. So does that answer your question? Yep. So like I said, if you're interested in these programs, there's about 100 of those in detail that you could go and look at online. Again, for example, the electronic equipment turning power off after some time, and again, development of such control devices or control algorithms for other devices. So anything that will save us power. Okay?
One question from online too.
Yeah.
Could you elaborate on the proposed DC circuits in homes? What sort of devices would be available to utilize these circuits? Given that most current power supplies are AC.
So like I stated in the beginning, in terms of a disclaimer, I'm the technology roadmap expert. I'm the technology management expert. I'm not the energy efficiency expert. So I wouldn't be able to give you the proper answer about the DC devices. But the idea is that we keep converting power so many times, and eventually you don't want to do that, and you just want to have DC power coming in, and you could use the DC power in appliances. For example, all these laptops are geared to use DC power, but you have all these big black boxes that again turns AC into DC, so you lose a lot of electricity over there, and you lose a lot of electricity when it's coming in. So while we have these devices developed for home, I think the challenge is to what kind of power is coming into the home, and as long as if we cannot change that, it's difficult to have other savings. Now, I know that we have a building now planned to be built downtown, on campus here, which again, one of the features will be being planned at this point. I don't know if it's finalized yet, but is that it will have DC power in, so that everything in there would be DC. That will be a basically display. But again, those types of changes require a lot of infrastructural changes, like changing, for example, shift to the EV or electric vehicles. So today, when you have so many gas stations around, so you need that type of infrastructure to be able to switch to EV comfortably. around the nation. So hope that answers the question. But if they can email me the question, we have experts who know each roadmap or who has helped us with each roadmap slide. I could just forward that question to them. Okay.
Any other questions? Well, once again, what's that?
So do you have any idea how, in percentage, that energy efficiency can save in percentage of current energy consumption? If you do it all, what you can do in the region, how much that would be in percentage of current energy consumption? Do you have any idea?
Well, percentage depends on the scope and the case, what we're talking about. But the energy efficiency programs have been pretty effective in the Northwest in terms of, again, lighting projects, as well as the projects such as Energy Trust of Oregon's services in identifying different losses in your homes. So it can be as efficient as, for example, replacing a hydropower plant or a coal plant, so that you don't have to build another one, or you don't use one, and they can range again from.
I'm talking, that used to be done earlier. I haven't read most recently Northwest Energy Power Planning Council. They used to do those kind of estimates in their multi-years annual plans. So I don't know with the latest technologies now how much is that energy efficiency taking percentage in as I ask you, energy consumption.
So now this one again, the roadmap is.
I haven't read the latest one, so I don't know. But
Okay.
I know earlier in 90s that was not at that time, at that level of energy efficiency technology was not so big, so high. It was less than 10%, maybe even less than 5%. But I don't know now. Actually, that's why I'm asking. Do you know maybe now?
Now,
10, 15 years after.
Again, what the roadmap shows, or the purpose of the roadmap, is where to invest our tax dollars, if you will, to gain, to help reach the power plant's goals. So these have not been measured yet, meaning these efficiencies have not been realized yet. So, but in the past, again, depending on the percentages, for example, lighting can provide efficiencies up to 50%. Again, just when you look at a single home, right? So it depends on what you're looking at and what's happening. Now, in our history, when you look at our history, we have had different economic shifts, and in the late 70s and early 80s, we had, some of you might be familiar with the nuclear power plants that were basically trashed because the expected demand did not materialize. Now, again, the expected efficiencies depend on expected demand, meaning if they materialize, then your expected efficiencies will also be realized. So it basically is a matter of what is being demanded. Okay?
Well, thank you, everyone, again. Please join me in thanking our speaker.
Thank you.
And we hope you'll stay to continue the discussion. Have a good night.